Now we're going to modify our edit distance function from the last practical to instead do global alignment. If you recall, in the last practical for our edit distance, we have a penalty of 1 for skip characters and for mismatches. But in reality, we might want to penalize certain kinds of errors more. For example, a skip character, we might want to penalize that more than just a simple mismatch. So we're going to do that. So I've already pasted in here my edit distance function, which I'm going to modify to global alignment. So to start with, here I'm just going to define the alphabet we're working with. And then I want to define a two-dimensional array which will have all of the penalties for the different mismatches we have. So I'm going to call this score. And we have 4 characters in our alphabet, so I'm going to make this a 5x5 array. So it will have the mismatch of each character to a different character, to each other character, as well as the penalty for skipping each character. So the top left 4x4 of this array will have the mismatches of each character against each other character. So A against A is a match, so we're not going to penalize that at all. A mismatch of A to C will be a penalty of 4. A mismatch of A to G will be a penalty of 2. And a mismatch of A to T will be a penalty of 4. So since A and G are both purines, right? Mm-hmm. Since those are both purines, they're more likely to have a mismatch there than A against C or T, which are a different pyrimidines. This is a different type of nucleotide, slightly different structure. So we're penalizing the C and T more than G, right? And then the last character in this row will just be if an A is skipped. So we're going to give this a penalty of 8. So I'm going to do this for each row now. So this is the row for C. So C against A is a penalty of 4. C against itself is 0. For 2. And then for the skip is 8. This is for G. So it'll be 2, 4, 0, 4, 8. For T, it should be 4, 2, 4, 0, 8. And then the last row will just be all skips, just like that. Did I get that right? Mm-hmm. Okay, so this is our penalty matrix that we're going to use.
Okay.
So now let's modify this edit distance function to use that. So I'm going to rename this global alignment. The first few lines here, defining D, just filling it out with zeros, those don't have to change at all. Now, these next steps are where we initialize the first row and the first column. So, for example, the first row of this matrix corresponds to if we were to skip the first I characters of Y. So we have to calculate the penalties for the skips for that. So the top left character in our array is 0. And then we're just going to, for each character in the first row, we're going to take the character immediately to the left of it and add the penalty of skipping the current character in Y. So I'm going to say, so I just want to take the range from 1 up to the end, since I don't want to touch the top left character. That will always be 0. And I take the character I minus 1, and I add the correct penalty from that score function. So I'm going to score alphabet.index of x at I minus 1. So this alphabet.index will give us the index of the current character in x in that. So it'll be a number from 1 to 4. And that will tell us what row to look at in our score array. And then we're going to take the last value of that row, because that will give us the penalty for skipping that character. Mm-hmm. Does that make sense? Mm-hmm. Okay, cool. And then we'll do the same thing for the column. So I want to go from 1 up to the end of this Y. I'll take the character directly above it in the column, and then I'll add on it score -1s, take the last row of that array, and then alphabet.index of y -1.
You need to do I-1 instead of -1.
Oh, right, yes. Now we just have to fill in the penalties here for our horizontal distance, vertical distance, and diagonal distance. So the horizontal distance, the penalty here would be if we were to skip a character in y. So we want to do this similar to what we just did above. Score the last row of that. I'll get the character at j-1 and y. And so this will just add the penalty for skipping whatever is the current character in y. And similarly for the vertical distance, we have to calculate the penalty for skipping the character in x. Now for the diagonal distance, this penalty will be the score for a mismatch between two characters. So we'll just calculate the mismatch between the current characters in x and y. Just like that. And then the rest of our function won't change. So we're still going to calculate the minimum of these edit distances for the current value in D. And then at the end of our function, we just return the value in the bottom right corner of this array.
So we only had to change 1, 2, 3, 4, 5 lines in the whole function. So
yeah,
it's pretty similar.
Okay, so now let's test this out with a few strings. So I'm going to just make up a random string x, and I'll set y initially to just be the same thing. And the edit distance between two identical strings, as we would expect, is 0. If we have a skip in here, if we skip a character, now we have a penalty of 8, which is what we defined in our matrix. If instead of a skip we have a replacement, say we replace G with a C, now our penalty is 4.
That's the transversion penalty.
Right.
Yeah.
If we replace G with A, which is another purine, now we only have a penalty of 2. And if we have maybe a mismatch there and then a skip down here, now we have a penalty of 10, which is 2 plus 8 for the mismatch and the skip. So that's our global alignment function.